Hey there, SOS 232 folks. Hopefully you're doing well. My guess is that while Module 3 was kind of new and maybe a little bit challenging because you had to do those sort of add-ons to make the bar graphs look good, as you began your journey exploring how to analyze categorical or qualitative variables, hopefully it wasn't too bad. But now we're going to up the ante. Well, talking about a single variable is important because it gives the audience an understanding of how to discuss things and analyze what's going on. As social scientists that you all are becoming, it's going to be important to look at the relationships between specific variables. We're going to begin our exploration in this module, and we're going to sort of go very nice and easy while still talking about some very formalized methods and terms. Remember to go to the workshop we have this module and check out what's really going on because I think it'll be really beneficial to each and every one of you all. Because honestly, as we're starting to figure out how to do these things, it gives us the opportunity to really talk about data, the relationships between variables, and the analyses that really explain the social world. So let's get started. Got a long journey ahead of us, and I think we got it, but we'll have a little bit of work to do. Let's get the ball rolling. So we'll begin our conversation with analyzing relationships and comparing categories. In PowerPoint, we're going to look at what's called a contingency table or crosstab data. And we're going to explore in this module practical evidence. What relationships may exist between two variables as we formalize what we call our hypotheses. It's going to be somewhat concept heavy, a little bit less heavy with statistics, thankfully, for right now, but we want to make sure you get started early to give yourself enough time to pace for this course. We're going to talk about setting up propositions, and then go into some tests of statistical significance, but we're really going to talk about more practical significance in these situations, as well as the assumptions that go along with running these tests. So let's get started. Much of social scientific exploration is a search for relationships between elements of people, so dispositions or properties, to explain theories that unite them. So, like, are smokers more likely than non-smokers to belong to a specific social class? Is race related to education level? Does income level relate to happiness? Does math anxiety impact social stats performance? I bet I know the answer to that one. Now, to determine whether these relationships exist, we'll often develop statistics from these separate populations and evaluate whether the difference may exist based on information present. So we'll basically take our data to figure out, do these relationships exist, as opposed to just anecdotes. We'll then determine to see whether our studies can infer that one variable has a relationship or an association or correlation with another. We have two numerical variables. Now, two variables, x and y, we'll call them, are associated or related if the value of one variable gives you information about the value of another variable. For the rest of the course, this is what we're going to be doing. We're going to be determining whether an association exists by comparing their descriptive values to see if these notable differences are existing. We'll often look into whether changes in response of one variable, so like going from folks with a graduate degree to ones with less than high school completed, changes the breakdown of responses of another one, the percentage of people who are not too happy. Now be careful. Association is not causation. This is another word or another term you may have heard as correlation is not causation, but just because there's a connection doesn't mean that one thing's going to cause another. For example, studying for a test could be connected to scoring well on an exam, but if you don't study, it doesn't mean you're going to fail. And if you study hardcore, it doesn't guarantee an A. But association is a necessity. It's necessary for causation because causation is basically a causal relationship. If I don't have a relationship, I can't say that if there isn't any relationship, how could I say that it was a causal one? If a relationship is not present, there's no reason to believe a causal one would be. But associations can provide evidence for us to explore potential causal relationships. So one thing causes another. Often, researchers will use a designed experiment, like in biology or even psychology labs, to determine whether causation occurs. And in survey research, this is a little bit different, though, because as you're doing a lot of stuff, just collecting data. You're just observing what's happening. I'm not saying you don't eat breakfast, you don't eat lunch, you don't eat dinner. What I'm saying instead is, oh, I might record whether we had breakfast or lunch or dinner, and then also see how the impact would be. Now, trying to claim that one variable causes another is much more difficult in these situations. So, while we'll look into relationships, associations, even correlations, we're not going to go so far to say that one component causes another. Now, there may be other higher level things that we could explore and analyze to sort of see whether this causation occurs, but we won't worry about it right now. We'll just go with the sort of more relaxed situation and just say whether or not a relationship seems to occur. So, for example, it's been found that there's an association between ice cream sales in a town and the rate of violent crime. Dun, dun, dun. Does this evidence suggest that ice cream purchases are increasing the rate of violent crime? Hmm. So you're saying, like, if I go to a Ben and Jerry's, big late night craving, I'm gonna go set fire to a bank? I don't think so. So in this situation, I think that there's things are not really actually related to each other. What could be related and what is likely related is what's called this confounding variable. We'll talk about in a second. It's that warm weather is impacting both. When it's warmer, ice cream actually sales will go up because people like to eat ice cream when it's warmer outside. Likewise, as weather gets warmer, the rate of violent crime will increase as well. So we'll see that sometimes there's something in the background that may be showing that these two things are related to each other. Now, a confounding variable is just a variable that's related to both the explanatory and response, the two other variables, in such a way that the effects of one cannot be separated from the effects of the other one. These cause spurious relationships, relationship between these two variables that are caused by some kind of confounding variable. Confounding variables explain why causation can not always be assumed, even if we see that there is a relationship. Might be missing a bigger picture. Another great example. Breast cancer diagnoses rose over 300% between 1973 and 1992. Was there a breast cancer epidemic? No. In fact, what really happened was the mammograms were starting to be implemented for screenings in 1976. When mammograms were implemented, that detected breast cancer situations much earlier. Because it was detected much earlier, it didn't have a time to spread and do more damage. And so while they were detecting these things, they weren't detecting other stuff, because that hadn't happened yet. So prevalence of a function, being able to correctly diagnose something, this is a good thing. And so when you see these increases or seeing these sort of relationships, try to figure out what was the underlying cause. If you can't figure that out, don't necessarily say one thing causes the other. Now, before you use your bivariate test, you need to set up your propositions. And propositions are just a clear, objective statement concerning the relationship between two variables. So, like, maybe does happiness or perceived happiness relate to education level? Maybe some other examples could be thought of like religion and politics or class and whether you have favorable or unfavorable views toward marijuana use or gun rights or etc. So we often want to see whether response changes for one variable impacts the descriptive statistics for another. Causation might be out of reach, but we can still explore whether associations are existing. And these associations work in reverse too. So if education level is associated with how happiness levels vary, then Also, the flip would occur too. Happiness levels is associated with how education levels vary. One isn't causing the other, but we can see where the relationships might be. To get causation, we may not have that. We need to have one thing would cause the other. It may not be able to be flipped. So that's why we like to say the association. It's a little bit weaker, but it does make sure that we're being honest. Now, the basic elements of propositions are formed in this what we call a symbolic form. Y and then the little tilde symbol X. Tilde symbol, it's usually, in the upper left-hand corner of your keyboard. And basically, we're asking how is X associated with how Y varies? Y is known as our dependent variable, something we talked about a second ago. This dependent variable is the variable that's focus of our analysis, so our response variable. In survey research, it's typically what we know as our disposition. It's usually our attitude, belief, behavior, or opinion that a researcher wants us to better understand. So typically, what we usually will try to lean into is to see certain responses and how it might be impacted, our dispositions impacted by certain different properties, which is then the X variable, the explanatory variable. It explains, hopefully, those differences in why. So in survey research, it's usually the properties, demographics, or household characteristics the researcher believes may account for these differences in why. So this is the variable you try to propose explain these differences and how the Y variable or the response variable seem to be changing. And when we assess whether these relationships exist, we're going to set up, with alongside our proposition, official hypotheses. And a statistical hypothesis is a statement about our population using our propositions. The null hypothesis and the alternative or our research hypothesis. The null hypothesis is really just, when I say null in ULL, that is basically saying there's nothing happening. So if I say a null hypothesis is H sub 0, that's basically saying there's no relationship going on. So if there's no relationship between two variables, X and Y, then we don't think that anything's causing or being related to the other part. Say no relation between happiness and education level mean that education does its own thing, happiness goes its own thing, and they don't really seem to coincide. The alternative of the research hypothesis is really what you are trying to prove. It's the competing claim that we're researching to try to be true because we want to disprove the idea that the null hypothesis, this pre-existing belief maybe, or even just the idea of nothing happening. We want to disprove that. So we want to prove something is happening. So in our analyses, alternative hypotheses are going to be something like there's an association between variables X and Y, or maybe variable X is related to how variable Y varies. So a good example of this is education level is then associated or related to happiness. And we have to be careful. To evaluate the validity the associations exist, we'll do this what we call a hypothesis test. And this gets a little tricky, but we'll sort of talk about it in sort of chill terms before we go into the formalities of things. Think of it like a courtroom trial. In a trial, the jury runs on the idea innocent until proven guilty. And so they need to decide between one of two possibilities. The person is innocent or the person is guilty. So we'll begin with the idea that someone is presumed to be innocent. So innocent until proven guilty, right? The prosecution will collect and present all available evidence to try to convince the jury to reject the original assumption, innocence, and conclude the person is guilty. If there's enough evidence, the jury finds the defendant guilty. If there isn't enough evidence, the jury will find the defendant not guilty. A not guilty verdict does not prove someone is innocent. If I burn down a building, because I bought ice cream, if I burned down a building and I was found to be not guilty, it wasn't that I didn't do it. It's just that the burden of evidence needed to claim that I was guilty of it wasn't enough. There was insufficient evidence to prove I was guilty. So we failed to reject the person as innocent. So an ideal situation, null hypothesis, sort of summarizing, basically innocent versus guilty. In our case, there's no relationship versus there is a relationship. Now, we're going to go ahead and we're going to test the propositions. How do we test our propositions? What statistical test do I use to test whether or not these two things are related to each other? That was a lot. I know there's a lot of concepts here. Take a short break, take a breather. Before going forward, test your knowledge, what you learned so far, in preparation for the quiz going forward. Ready to roll? Let's go. So let's test our propositions. And we'll try to look at the idea, so basic statistics. Bivariate statistics allow us to test our proposition. So this idea is, the criteria is, how is y related to x? The type of bivariate statistics you use is dependent on the types of variables in your proposition. So in modules 2 and module 3, I actually had you all talk about and discuss and learn to write up quantitative variables and categorical variables. Quantitative numeric versus the qualitative or categorical have different purposes. And they're also, the combination of the two will have different ways of analyzing. If both x and y are numeric, we're going to actually look at what's called correlations or regression in module 7. If x or y, if one of them is numeric and the other is categorical, we need a different type of test. Typically, we use a means test, either a t-test or ANOVAs. And ANOVA we'll talk about more in module 6. But for this module and the next one, if both x and y are categorical, we'll typically use a different type of bivariate statistic, a crosstab test, which is eventually going to become a chi-square test in module 5. So when we explored univariate data from one population, we usually use frequency distributions to group our data. When we have two variables, we often want to see how do they go hand in hand with each other. And this is known as bivariate data analysis. When we explore the frequencies of individuals over two variables, we produce both a contingency table, crosstabs, two-way table that summarizes both variables simultaneously. Each box in this table, so each of these things inside this table, so the ones inside where they sort of cross are known as a cell. They represent a joint event. So in this case, the idea of average and pretty happy happen simultaneously. The overall total is in the lower right-hand corner where the totals meet. So it looks like 506 out of 2016 respondents reported having an average income and a pretty happy attitude. But just like we want to get percentage for univariate frequencies, we can use the percentages for contingency tables as well. There's joint percentages and percentages of a joint event occurring relative to overall total. And so a joint event is basically saying that 30, in this case, 368 over 1955 would be 18.8% of the population. And these marginal percents are basically just the stuff in the columns, the total column. So there's total females versus males, and then the religion aspects here. These percentage events represent the margins of the contingency table, basically relative to the total. So if I were to look at these percentages, we can see that roughly 19% of everybody that responded with having no religious background, versus for males, it looks like there are 44.8% of individuals who identified as male on our GSS survey for the sex variable. Now, what if we had pre-existing information, like which sex they responded with? How might that impact their religious viewpoints? That is an important thing to say. So if you identify as female or if you identified as male, you might have different responses. So we might want to see what is conditioned or given we have some sort of additional variable. So given the person responded as male, I go down, I can see that 31.1% of them consider themselves to have a strong religious faith compared to 40.8% who responded as female. Maybe there's a connection, a relationship between whether someone identified as male or female and the strength of their religious faith. We can deal with these conditional percentages in the column percentage component for GMOB. You'll see that in the guidelines and everything and how to do this stuff. And you can find these percentages pretty easily. So now, the bivariate test allows us to test for propositions. We want to say, well, what kind of variables are they? Well, we got X categorical, Y categorical. So a crosstab is when you sort of go ahead and you overlay those things. A frequency distribution is really the only way to summarize this type of data. When you overlay one frequency data distribution on top of another, the crosstab, deals with the counts and compares where the cases would be represented in one category or the other. So let's try. Pause, pause, pause. Okay, let's try a practice problem. Let's use the GSS for 2018 to look more closely at who is more likely to favor or oppose gun control measures through the following GSS question. Do you favor or oppose a law that would require a person to obtain a police permit before he or she could buy a gun? So I'm going to think of some sort of variable that would make sense along with this stuff. Maybe gun control could be impacted by education level. That makes sense. Maybe I think that different education levels, maybe something goes on with a higher education level and the impacts of gun control. I'm taking that pause because I want you all to realize that I'm asking you all, and you start to write these things up, just think about it. I think for the most part, in terms of the social scientist element, I think the opinion parts, you all got this down. Take that breather to really analyze all these pieces. Now, Americans with maybe higher levels of education will be more likely to support stricter gun control measures because they have read more on reports regarding gun violence. Am I thinking that this is correct or not? Maybe. I'm hoping it is. I'm trying to shape because I'm trying to theorize. I'm trying to go back to what I might have read upon or, establishing some sort of literature review. This is what you do for going back and, your papers that you write that are not statsy and more concept related. You go and you do a literature review and you read up on things and you sort of see what the results are and why you might want to test these things. So that's your sort of research alternative hypothesis to figure out where you want to go. And the null hypothesis is really just the possibility there's no relationship. So in this case, the null hypothesis would be there's no difference based on education level with respect to Americans' positions on gun control. We're going to see, or at least explore, whether or not there seems to be evidence to suggest that these two things are related to one another. Now, we'll look and we'll see things like favor and oppose versus different types of education level. The dependent variable are going to be typically what we consider the Y variable. We're going to go with rows, while the independent variable or the explanatory variable are these going to be known as our columns. And the percentages are then our column totals. So say put gun law and degree in there with column totals, and that's going or column percentages. That's going to, run through and get us our analyses for these conditional percentages. Make sure you go through the Jamovi short video on how to run these things because that's going to be super useful for your analyses. And you get something that looks like this. And note, I can look and see the favor versus oppose and the different levels of educational attainment. And you can see the breakdown of these, but now all these look like 100 because these are all going to be column percentages. We see favor and oppose for bachelor 75 to 24, 73 to 26, 69 to 30, 74 to 25, 68 to 31. And we can sort of see this breakdown and note that maybe there isn't a big difference. I see some differences, but there may not be a lot. Now, we're going to look at things like tests of significance. These allow the researcher to determine whether the findings are generalizable to the population. As a good reminder is that this stuff is survey data. It is sampling from a population. So we need to analyze how to take what we get from our survey and see, does this seem to tell us something about the population? Is there evidence to suggest that? We'll look through this stuff through two different lenses. The first one is through a practical significance lens. That's what we're going to talk about in Module 4. In Module 5, we're going to go into statistical significance and sort of see whether those differences seem to exist from a very formal statistical understanding. They both of these things allow us to answer the question, how confident that we can be the relationships that we are observing in our sample data reflect something broader and generalizable to the population. It's a big question. As we start to look at these sample data statistics, these values, we don't know whether this is actually generalizable enough. And so we sometimes want to be cautious on whether or not we have enough evidence. So when do you use a test of statistical significance? The answer is only when you have good data. And good data is a sample that is representative of the population. So let's make some distinctions so we are more formalized in the way we're talking about these things. So it's a good reminder, populations, one, scientists and social scientists are always interested in studying a population and understanding what's really going on there. Now, most of us are naturally already moved to that level of analysis by inferring from the sample of the GSS respondents to the population at large. So remember, one of the major values of science is building generalizations and theories about how the world works. This should feel very much like the sociological imagination that you may have learned in an intro sociology class. Now, our sample is really the smaller set of what's going on. So we can really never survey everyone in the population. How do I get every single person? You don't. But we can get a random sample and try to get something that looks like the population. We strive drawing our sample that represents a good cross section of the population so we can fit this stuff. In fact, get information that looks like it's generalizing about the population based on our sample. Now, who gets collected and responds can change from sample to sample, which is sometimes why our descriptive data differs from year to year. Now, to evaluate whether our data is good data, we should always be sure to evaluate how the data was collected and whether the sample is representative of the population. So, representative sample basically means the sample reflects more or less the general characteristics of the population. And honestly, the type of sample we collect, including how many people we sample, is really important. To get a good representative idea of these sample situations, how to make a representative sample, think of the population as like a big old stew. And we got a full collection of various groups of items, potatoes, carrots, corn, protein, so on. And the sample for our population would be akin to getting yourself a portion of the stew. A representative sample, what we're aiming for, would be like getting a big old bowl of stew. It's still about the same amounts of each item, but in a smaller size. This event is more likely to occur when you have a large sample. when we get really small samples, we only get like 20 or 30 people, we run the risk of missing out on vital groups which represent our population. This could be seen as obtaining a stew from like a smaller cup or something like that, and it has me in agreement of the elements, but we might be missing some of the ingredients. Like maybe you have too many potatoes, not enough carrots, too much corn, and so on. And so it doesn't always represent the dish as a whole. Now, when working with survey data along with evaluating sampling methods, it's also important to quickly review we know as our response rates. And response rates represents people who received the survey or were asked to participate who actually went ahead and completed the survey. Now, good response rates, if you can get between 60 to 80%, that's thought to be pretty good. Not everybody's going to respond, so having that amount of people, that's legitimate. And you have low response rates, and there's plenty of research studies that report on survey data with response rates as low as 30 or 40%. So about roughly, 3 out of every 5 people just don't respond. Why are they not responding? It's something to consider and critique. Results like these would suggest that there's a response rate bias in the reported findings. Now, a bias sample is one that overrepresents the demographics of one particular group or another, and subsequently underrepresents the other groups. And so if a sample is not representative of the population, findings of the sample cannot and should not be generalizable to the population. In this case, we shouldn't be using our test of statistical significance to make our generalizations. And unfortunately, social science is ripe with research and studies that use bad data, so data that's unrepresentative of the population to make generalizations about our population. As a future social scientist, it's your responsibility to be constantly skeptical of the research that has come before your own work as to improve on the research and study design to advance our knowledge and understanding of the world. Be fancy, folks. So questions to always consider, is the survey data representative? What was the response rate? So is the GSS good data? There's some critiques on the GSS and debate on whether it's a good representation of the US population. General consensus is that the sampling design yields pretty good results, and the sample each year is, by and large, representative of the US adult population. In terms of response rates for any year, the GSS, it's usually somewhere between 72 and 82%. Pretty solid for usual survey standards. And we consider the GSS as relatively good data, but feel free to always be skeptical. Critique whether they respond to certain things is very different to whether or not they were truthful about it. For those who might be interested, go ahead and check the General Social Survey Report from 2016. All right, another big dose of stuff. Take a short break, take some Zen mode, answer some of the quiz questions. And let's go with the next part. All right. Let's get through the rest of kind of the story. Testing for significance. So what statistical tests should I use? And how should I compare the practical significance and the statistical significance? We'll focus on statistical significance in Module 5. Right now, we'll focus on, instead, the practical significance component. So let's start building up these things. First, we'll look at the symbolic form. Y tilde X is gun control related to education level. And we'll start with stating your research or alternative hypothesis who's more likely. So like this is all sort of saying what we've said before. Americans with higher levels of education will be more likely to support stricter gun control measures because they've been reading more reports regarding gun violence. This is just my sort of thought and opinion that I want to research on. This is me looking at maybe other literature reviews, things like that, and really setting an idea of what I think. Nothing more than kind of your own opinion on things. Show me your personality and reasons behind these stuff. Stating the null hypothesis, also with the possibility there's no relationship between the two. Reinforces the researcher's objectivity and that they are letting the data speak for themselves. So there's no difference based on education level with respect to Americans' position on gun control. Now, when performing statistical analyses, we typically want to examine our hypotheses from both a practical as well as statistical standpoint. The practical significance viewpoint has us look whether descriptive statistics and compare them to decipher whether meaningful differences seem to exist. Statistical significance viewpoints, the next module, is going to have us, or Jamovi, use mathematical statistics and very fancy complex procedures to determine whether these differences exist beyond the reasonable doubt, so whether we got an offbeat sample that year. When we have a large data set, this GSS, we typically require the statistical significance to exist. But more data sometimes claims that differences exist we don't think are huge. For that reason, we ideally want to have a practical difference as well. So we'll talk about practical significance. And the basic elements for practical significance is one, find the category of the dependent variable, the row, that you want to explore, and circle the largest and smallest percentages of that row. Then compare the lowest and the highest percentages across that category of a dependent variable using what we call a percentage difference rule to determine whether a practically significant relationship exists. So what I mean by that is I'll go ahead and I'll take some row and I'll examine based on these two columns whether or not there seems to be a difference. If there seems to be a significant difference, a noticeable gap, this gives us some good gut instinct that maybe there is a practical way of just sort of saying, do these differences exist? I think so. Now, formalizing it, I would consider it these sort of key points. One, I think there's no, or at least a weak relationship. If the difference between this sort of highest and lowest percentage is less than 8 percentage points, this is where I think that maybe it's too close to call. It could be some differences just based on that sample from year to year. And so I don't feel comfortable enough suggesting that if there's, especially with multiple categories, if there isn't a big enough difference among them. If I see that the differences are between 8 and 20 percentage points, so basically the only thing you're going to do for this class that feels very mathy is taking the highest and lowest and subtracting them. User calculator, I have no problems with that. Find that difference and say, is it between these two differences? If so, we think that there might be a slight or a moderate to even a strong relationship. So when I go I think this is a really strong relationship. That's if the percentage difference between the lowest and the highest is over 20 percentage points. This seems like it goes from strong to really strong or even robust, that there's a very clear difference between these two groups. All right, let's see this example in action. Gave you a bunch of words that actually do this stuff to sort of see what these differences may be. So let's examine the no religion variable, like I said before. And we'll see if someone identifies as female versus male. Based on these differences, about 15.8% of females identified having no religion, while 24.7% of those who identify as male feel the same way. So let's do some math. 24.7 minus 15.8 is 8.9. 8.9, is that bigger than 8%? Yeah, it's actually, between 8 and 20. So I think there may be a relationship, at least a moderate relationship, existing between sex and religiosity. So let's go to our Dunn-Law example to sort of see this in motion. Let's try it again. The highest one out of all of them was actually the bachelor's degree, 75%, 75.6%. The lowest in favor of gun control laws was less than high school, 68.4%. Now, our claim was that maybe higher levels of education were more likely to support stricter gun laws. All I'm trying to do is try to find some relationship. Well, if I look at the difference, 75.6 minus 68.4, that's only a 7.2% difference. Now, all I did was take 75.6 minus 68.4. It's almost there, but it's not quite 8%. Based on the percent difference rule, I don't think that's enough. I think there's not much of an effect there to determine this difference. So I don't think there is much of a relationship between education level and opinions and gun control. I feel good. Is it too much? So take a breather, pause again if you need to, and now sort of go through all the motions to explore those relationships and the write-ups that go along with it. Setting up your propositions, does education level matter in explaining one's position in gun control? I'm setting up all these things. This is all we did before, but sort of just setting up all the stuff and talking about that all over again. Passing propositions. So we'll use a crosstab to test the percentage of your percent difference rule. And we'll write this stuff up accordingly. First part, and note what I'm doing here. This is also in the rules of writing, but note that what I basically did was take all these pieces, with the exception of the last couple sentences. We took all these pieces and already wrote about them. I wrote about it sort of here. I took that question of whether they're related to each other. And I already talked about the differences when I examined that stuff from a percent difference rule perspective. So does education level matter in explaining one position on gun control? Education in higher levels of education, Americans with higher levels of education, are maybe more likely to support stricter gun control measures because they may have read more reports on regarding gun violence. Comparing percentages show that those in favor of gun controls or control laws are highest among those with a bachelor degree at 75.6%, in comparison to those who finished less than high school at 68.4%. The 7.2% difference based on a percentage difference rule does not suggest that there's a relationship between education level and opinions on gun control. All this was things that we already wrote up prior. Now I'm just putting it together. And now I'm going to go talk about future research. While these findings report on 2018 data, it'd be interesting to look at this relationship in 2026 to see how we depict gun control and gun use in our country. Furthermore, it may be interesting to explore whether specific restrictions may be endorsed more than just outright bans. And this is all just me sort of just blah, 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 talking. Nothing super formal, just your own thoughts and opinions on that. And remember to review the rules of writing research in the modules. All others follow the stuff for reporting crosstabs. You'll need these tools for reporting practical significance when writing up your findings to do well in the blog posts and homework assignments going forward. And make sure to learn how to do the crosstab results and test for practical significance in Jamovi using General Social Survey and watch the Jamovi short video. You'll need these tools running crosstabs to do well under your blog posts and next module's homework assignment. A break, take a breather. We did a lot. And then test your knowledge. And other than that, you got this. Take care, folks.